Hello, hello, and welcome to this video. As I said in my previous video on PostgreSQL, I'm going to present a system design interview question, but it is not a theoretical question, it is rather a practical question. In system design interviews, usually you are asked to design a large scale system, some sort of system, YouTube, AWS, something like that, WhatsApp, or Uber or Airbnb, you want to design a large scale system. So the question is, one of the parts of that question, or even in real world, whenever you want to develop a large scale application, the first question is what database should you choose? So certain popular choices which people pick are MySQL, PostgreSQL, Firebase, MongoDB, or Azure Cosmos DB or DynamoDB. But there is a downside of each of these choices. For example, MySQL and PostgreSQL are notoriously hard to scale. It is possible, but it is hard. You can do sharding, you can do replication, you can use something like Citus or Pgdog for PostgreSQL. You can do sharding for MySQL or use Vitis, thereby losing the ACID property of MySQL and so on. On the other hand, if you pick something like Azure Cosmos DB, MongoDB, or say the third one was Firebase. So these are document-based databases, and document-based databases are nasty because they go against the very basic of database design. That is, the normalization is basically big time screwed in those databases. And there is quite a bit of penalty because of that. An example would be to demonstrate why document-based databases are bad. So as an example, you can pick Stack Overflow. So Stack Overflow, if you look at the typical information is questions and answers and comments. And if you choose document-based databases, you would be tempted to put the question, answers, and comments in the same document, because that's how you get benefit of document-based database. In one round trip to the database, you fetch everything, question, answers, and comments. So it is quite natural to design it that way. Now let's look at the downside. Suppose there is a question and now two people are answering and they submit their answer. Now you assume that the answers are submitted at the same time. So the app server will fetch the document, modify it, and write it back. Now, because of this, one of the answers will overwrite the other one. The solution is to take a pessimistic lock. And once you take a pessimistic lock, the entire performance goes down the chain. The other disadvantage of these document-based databases is all of them are AP, okay? And they do not give you ACID guarantees. Complex querying is possible to an extent, but you don't get all of it SQL. So, and the last one was DynamoDB, I believe. So DynamoDB, if you pick, the problem is the same as with Firebase and Azure. That is, you are tied to a vendor. Okay, there is vendor lock-in. So if you want good of all the words, you should be able to freely query. It should be fast. It should be SQL and stuff. And I should be able to scale painlessly. There should be disaster recovery options. So there are two databases I'll present for this design. One is CockroachDB and another is ScyllaDB. So whenever you need ACID or SQL's guarantees, which it provides transactions and all that, you choose CockroachDB. That is one of the reasons why I have started the playlist of PostgreSQL, because once we learn all of PostgreSQL, we can naturally transition to CockroachDB because it is wire compatible with PostgreSQL and most of the queries or features of PostgreSQL are built in CockroachDB. ScyllaDB is basically a Cassandra clone. It is no longer a clone, it has evolved into something more. It also supports DynamoDB-like queries. And the best part of ScyllaDB is that it is crazy fast. So whenever you don't need your ACID guarantees and SQL-like features, you can use ScyllaDB for that part of your application. And it is the fastest database right now, I believe, in the market. It is so fast that you don't even need a Redis cache. Okay, if you look at the documentation, you will see that there are references of no caching for ScyllaDB. So whenever you have that question, you can pick a combination. Now, suppose you have a restriction that you don't want to use ScyllaDB, or you have to choose just one database. If you have to pick one database only, go with CockroachDB. If you ask me what is the downside of these databases, the downside is that both are commercial and you need to pay. But I am convinced that every bit of payment to these two databases is worth every cent. So if you have to pick only one database, go with Cockroach Labs. The other downside, which I believe is CockroachDB is programmed in Golang. So that is something I don't quite agree with, but it is what it is. If you can write databases in Java like Cassandra, you can certainly write in Golang. And there are downsides, yes, of that. But someday in future, I hope that somebody would take the entire design of CockroachDB and write it into something like C, C++ or Rust, and that would alleviate that concern as well. So sometimes we have to wait for future to become present. So next time, if you are asked a question that what database would you pick for your system design, go with CockroachDB and ScyllaDB as a combination, and you would have a wonderful system which will scale painlessly, which will be highly performant, and you will have a lot of features right there. And the thing is that why I like CockroachDB is that it is just absolute blast of a database. Apart from the Golang pane, I don't see any other database coming close to CockroachDB. Of course, in terms of speed, it is not the fastest, but in terms of feature, it is so much packed with features that, no other database comes close. Now, the question is that what if you don't want to pay at all? Okay, suppose your restriction is that I want a free database. All right. You don't want to pay to ScyllaDB or CockroachDB. Then I believe that once you put the restriction that you want a free database, free as in free beer, then I believe you will have to take a bit of pain. And the solution would be PostgreSQL. I have earlier created a video on this with the PostgreSQL, how to scale PostgreSQL with the Pidgeydog and Citus. And that is what you should go with. PostgreSQL, you can scale to a large extent. The main pain of PostgreSQL is that when you need to upgrade, when the major version changes, then upgrading PostgreSQL becomes a pain. And when you have a cluster of databases, the pain is a lot more. But yeah, that is a known issue of PostgreSQL and documented, and how to do it is already well known in the community. So if you don't want to pay, go with PostgreSQL, and if you can afford the payment, go with CockroachDB and ScyllaDB combination. And if your application does not need the SQL guarantees and ACID and transactions, and you can do with the predetermined queries, you can sacrifice some of the querying capabilities, and ScyllaDB is your answer. So once my Python and or Rust and JavaScript playlists are a bit complete, I will start doing web applications, and I will show you how you can make use of CockroachDB or ScyllaDB. We will start with PostgreSQL, and then we will include these databases as a backend, and we'll see how the performance works. So I will end this video here, and I hope that you have enjoyed this video and found this video useful and informative. So I thank you for watching the video, and I'll see you tomorrow in the next one with another PostgreSQL video where we are discussing operators and functions in chapter 9 of the documentation. So I welcome you to that read through, and link to the Postgres playlist will be in the end screen, as well as there will be the pgdoc and Citus video link. I will show you in the end screen link. So you can go ahead and watch the video on pgdoc and Citus on PostgreSQL and how we can scale PostgreSQL. So once again, I thank you for watching the video, and I'll see you in the next one. Till then, keep learning. Enjoy.